makeup of our grid is changing quite a lot. We're going from lots of big fossil fuel power stations and we're decarbonising.
The grid is at capacity. There's no more allowed on. Those cables that we have limits.
With growth in all scales of wind and solar PV and low carbon technologies, we need to find ways of being able to manage those constraints on our network.
The Ark Project is designed to connect renewable generation to the distribution network as quickly as possible at minimal cost. We're looking at 3 areas. There's the planning side for developers, there's the commercial side, and then there's the actual technical side and how to get renewable generation onto the existing network without reinforcement costs.
The challenges that we are facing before connecting and operating the wind farm are huge. We have the consent challenge, which is a very major hurdle that every wind farm has to go through planning consent, and this might take many years. And then we have to connect to the system to start generating electricity and exporting to the network, which is now in a very constrained network. This is very, very difficult, and we are facing many, many problems with that.
The online curtailment tool is a product that we're developing through Ark to offer up a service to customers seeking a connection, giving them early visibility of what the likely constraints are going to be. The advantage is the speed in which the customer can get access and the information required to make informed decisions.
The technical challenges are physical. Cables can only carry so much electricity, and so we have to work within those safety limits. We are developing an active network management server that uses real-time data to control renewable generation.
Effectively, active network management is a very clever computer program, operating at very high speed, coming up with new set points every 600 milliseconds. If generation into the network is excessive, it issues constraint instructions to various generators. Because it's operating so quickly, we have real-time control. Therefore, we can operate the system far more efficiently and connect more generators.
We've developed over the last year a very positive engagement process with National Grid, and we hope that by the end of 2014 we'll be able to issue our first commercial offerings to generators who are currently facing constraints around transmission.
The benefits that we are hoping to get from the Ark project is to get connected earlier in the system when we don't have to do all the transmission reinforcements, and also when we are connected to minimize the time that we are curtailed during an outage.
Being able to get renewable generations onto the network allows the community to generate an income. If a community project can connect beneath a constraint, then they can really harness that electricity and that benefit for themselves.
What we have seen in UK Power Networks is a significant increase in the interest and actual connections of renewable generation. This boom, driven by the government incentives, has had a significant effect on the available capacity. So we are looking to develop new solutions, new products that we can help distributed generation customers to get access to networks in cost-effective ways. The Flexible Plug-and-Play project is focusing on developing solutions for connecting renewable generation in constrained parts of the network. One of the typical examples that we started working with was a connection that the site of the wind farm was only 500 meters away from the point of connection that we would normally be able to allocate, but due to the constraints on that line, we had to offer that customer an 11 kilometers underground cable to a different substation that had capacity, which resulted in a multi-million-pound connection offer. The Flexible Plug-and-Play offering was based around the principle that the electricity line is full, but is not full all the time. So what we can do is connect the generator on that line, having the ability to control their outputs through the bespoke wireless communications network that covers the whole area. So we've developed a commercial contract whereby the network operator has the ability to regulate the power output of the wind farm. So when we see the flow on the line reaching the operational limits of the line, we send a signal to the generator to reduce their output. UK Power Networks has committed to embed this innovation into standard business practices in 2015.
Larrick Power Station is a lifeline service for Shetland. We're not connected to the national grid here, we're an islanded network, and we supply 12,500 homes, schools, businesses, hospitals, and we're responsible for keeping the lights on 24/7.
The power station on Shetland is at the end of its useful life, so we're basically on a massive opportunity. We're going to be able to build a new power station. And what we want to do is turning the whole model on its head. Nines is kind of the future of the energy network. At the moment, what we have to do is turn the power station up and down as you switch on and off load in your house. What we want to do in the future is being able to take the wind energy that's available when it's available and adjust demand in your home to allow us to operate the system. So what we're trying to do is store energy in people's homes so they can get a hold of that energy when they need it.
We're looking to install new immersion water cylinders and storage heaters in customers' homes. The devices are far more efficient. They'll store the energy until the customer needs it. They'll be more controllable, and because of this increased efficiency, there should be a reduction in their energy bills.
The low-cost energy storage solutions that we're coming up with in Shetland could be directly applied to the UK and help to solve some of these problems as they come along.